Hello everyone, welcome back to my YouTube channel. I hope that you guys have watched the very first video that was Introduction to Deep Learning from the Deep Learning playlist, and now in this particular video we'll be looking into a topic which everyone should understand before moving on to the algorithms in deep learning. In this video we'll be looking into the difference between machine learning and deep learning. Machine learning and deep learning can be differentiated based on the following points. There are several points, out of which I have picked some of the most important points on which we'll be seeing the perfect difference between both these topics. So you can see these are the points. First is training data size, feature engineering, model complexity, performance, generalization, computational resources, interpretability, training time, domain adaptability, data efficiency, and deployment. Through these points, I will try to cover almost every single difference between these two topics. So, let's start with the very first point, which is training data size. We will see in both the cases how much training data size is required with an example. So, when it comes to machine learning, the best part is that machine learning works well even if the training data set is small in size. Whenever you have limited data and onto that limited data you want to perform some modeling through machine learning, you can use machine learning. Almost every single algorithm present inside machine learning works well even if few training samples are fed into the model. For example, using decision tree classifier from machine learning can give you good accuracy even if you feed a few hundred samples for training. So this is a speciality of machine learning, that it works well even if the training data size is small. Now let's come to the deep learning. When it comes to deep learning, it requires larger training data sets. Unlike machine learning, it requires larger training data set to handle the complexity of models and reduce overfitting. It is also known that larger data sets will capture rare events. Also, it provides more data variations. For example, training a deep neural network for image recognition will require thousands or millions of labeled images, especially when it comes to complex images. When you provide more data, it will extract complex structures which will make the model more robust. So I hope the difference between machine learning and deep learning is very much clear with respect to training data size. Now let's have a look at the other point, which is feature engineering. If you remember, in the previous video also I have given you an idea about feature engineering that is done in machine learning as well as in deep learning. So let's have a look at it again in detail. Now when it comes to machine learning, feature engineering has to be done manually. Whenever any unstructured data is provided to the machine learning engineer, the machine learning engineer will have to use some of the methods to extract the meaningful feature from that unstructured data manually. One simple example is that in spam email classification, features like word frequency and email metadata with some other important features has to be manually extracted to train the model. And for manually extracting this meaningful feature, we have the methods like HOG, SIFT, etc. Now since we have to perform the manual extraction, it becomes a time consuming task and there is no guarantee that those extracted features will give the best results. Now when it comes to deep learning performs automated feature extraction, which makes it amazing. It uses the concept of layers. The hidden layers in deep neural networks are responsible for extracting the features. The initial hidden layers are responsible for extracting simple features like edges, curves, etc. And these subsequent hidden layers are responsible for extracting complex features. You can see the example says that in image recognition also, deep learning models will extract the simple features like edges, textures, and complex features like shapes directly from the pixel values. That means the unstructured data. Here we do not have to manually extract and feed the structured data or the structured features into the model. We just have to feed the raw data and it will automatically do the feature extraction as well as modeling. So this eliminates the task of manual feature engineering. So I hope this difference between machine learning and deep learning with respect to feature engineering is clear to you all. Now let's move on to the third difference. And the point here is model complexity. Now when it comes to the models that are made through machine learning, they are relatively simpler models as well as their architectures are also simpler. For example, the models that are made through the algorithms like linear regression, decision trees, support vector machines, logistic regression, which are having fewer parameters and layers into it, are relatively simpler. It doesn't mean that every single model in machine learning is simpler. Support vector machine with more number of parameters becomes complex. But generally, when it comes to the comparison between machine learning and deep learning, machine learning models are relatively simpler and their architectures are also not complex. Now, let's come to deep learning. Deep neural networks has complex architectures and this complexity goes on increasing as and when the parameters and layers are added to it. Now, when the unstructured data that is provided to the deep learning model is very much complex and a lot of intricate features has to be extracted from it, then in that case, there is a requirement of increasing the parameters as well as the number of layers to the architecture of deep neural networks. So in that particular case, the model becomes so much complex that it requires a lot of computational resources. And that is why in comparison of machine learning, deep learning models are a lot more complex. So I hope the difference between machine learning and deep learning with respect to the point model complexity is clear to you all. Now let's move on to another point, which is performance. When it comes to machine learning, it provides good performance in almost many tasks. Right from simpler domains to relatively moderate domains, it gives good performance. For example, in sentiment analysis or credit scoring, it gives moderate to high accuracy. But machine learning cannot perform well when it comes to specific domains, which are covered by deep learning. Now, when it comes to deep learning, it is known for its achievement of state-of-the-art performance, which means it achieves the best results when it comes to other methods in a specific field. It showcases the cutting-edge capabilities of the deep learning models. Deep learning models are known to achieve the state-of-the-art performance in the tasks like image recognition, speech recognition, and natural language processing. It surpasses the old machine learning approaches and gives a cutting-edge performance. So, performance-wise, deep learning is the best. So I hope this particular difference between machine learning and deep learning with respect to the point performance is clear to you all. Now let's move to the other point of difference between machine learning and deep learning, and the point here is generalization. So when it comes to machine learning, it may have limitations in handling the complex data. Now this complex data may include some of the unstructured data. For example, the machine learning models may find it challenging to understand the unsegmented audio for speech recognition, which is unstructured. So when such complex and intricate data is given to machine learning models, it's not the cup of tea of machine learning. And this drawback of machine learning is handled by deep learning. Deep learning models can generalize well on complex as well as unstructured data. The model complexity might be huge, it might require a lot of layers or parameters, but the end result will be the best, even if unstructured and complex data is fed into the system. Deep learning models can perform well on understanding the unsegmented audio for speech recognition, as well as it is also expert in identifying the objects in complex scenes also. And this is the major difference between the generalization point between machine learning and deep learning. So I hope this particular point is clear to you all. Now let's move on to the other point, which is computational resources. Till now, whatever information I have provided, from that you can give a guess that what exactly the scenario is when it comes to computational resources. So you can see that machine learning requires less computational power because the model complexity is less here. Also, it doesn't handle large or complex data or unstructured data. Therefore, it requires less computational power. For example, it can be trained on standard hardware, But it's not the case when it comes to deep learning. Deep learning demands significant computational resources, that is, a little higher than the machine learning. Now, to be precise, deep learning demands this when it comes to deep neural networks with larger datasets. If complex unstructured data is fed into the system of deep learning, then it will surely require large computational power to train it. It often requires GPUs, which is the graphics processing unit, or it can also require the specialized hardware architecture or accelerators. So I hope this particular difference between the machine learning and deep learning with respect to computational resources is clear to you all. Now let's move on to the next point, which is interpretability. This is the most important point that is to be noted for sure. Interpretability means explainability. Now when it comes to machine learning, the models are more interpretable and explainable. Now what does that mean? Let's understand it by an example. Let's say we have used a machine learning algorithm, that is decision trees, for classification. Now in a decision tree, the entire path from root to leaf can easily explain the decision making process. That means we can easily understand and debug that on what basis we have got the output for this particular data. We can easily get through the process, we can understand and analyze on what basis what conditions are met, which clears that machine learning models are more explainable. That means we can debug the process. But when it comes to deep learning, the models that are made through deep learning are often considered as black boxes. They are referred to as black boxes because they are challenging to interpret as well as to understand when compared to the traditional machine learning models. Now this is because of the complex nature of deep neural networks, as it consists of multiple layers of interconnected neurons, as well as it also includes nonlinear activation functions and transformations to capture the relationships between data. And that is why when we try to debug or interpret, we cannot easily do it. Also, there is a lack of transparency in feature selection because the model itself selects the features, unlike in machine learning. And due to all this, deep learning models are considered to be black boxes, which means that they are not interpretable. So I hope the point interpretability is clear to you all, and the difference between machine learning and deep learning with respect to this point interpretability is also clear. Now let's move on to the next point of difference between machine learning and deep learning, and the point here is training time. So again, you can guess this easily. When it comes to machine learning, the training time is relatively faster because the complex models are not present here, as well as the unstructured data is not provided and not supported in machine learning. For example, training a logistic regression model can be very quick. But when it comes to deep learning, it takes longer time to train the entire data, especially for complex models. As you all know, deep learning supports larger datasets. So as the training data increases, the training time also increases. For example, training a deep neural network for image classification on big data may take several hours or days, even weeks, to train the model. I hope it is clear that machine learning models take less time to train and deep learning models take more time to train. I hope this point and the difference between machine learning and deep learning with respect to this point is clear to you all. Now let's move on to the another point, which is domain adaptability. Now when it comes to machine learning is suitable for a wide range of domains and tasks. It doesn't mean that it is suitable for every single task. Commonly, ML models are suitable for text classification, recommendation systems, and fraud detection areas. We can also use it in several other domains, but it is not that suitable when it comes to larger data. Now, if we talk about deep learning almost covers every single domain. It can be adapted to various domains and tasks. For example, DL models are adapted for image recognition, natural language processing, and autonomous driving. So you can see that on complex domains also deep learning works the best. So I hope this particular point of domain adaptability and the difference between machine learning and deep learning with respect to domain adaptability is clear to you all. Now let's have a look at the another point of difference, which is data efficiency. When it comes to machine learning models can work well even if the limited data is present for training. For example, a support vector machine model can achieve good accuracy even if small labeled datasets are present. In the case of machine learning, it can achieve optimal performance even if datasets are small. But when it comes to deep learning, it requires larger labeled datasets for optimal performance. If small amount of data is fed into deep learning system, then it won't acquire optimal performance. For example, for tasks like image recognition, deep learning models may need thousands or millions of labeled data image to have a generalized model that is effective even if complex structures are present inside the images. So I hope the difference between ML and DL with respect to data efficiency is clear to you all. Now let's move on to another point of difference, which is deployment of model between machine learning and deep learning. As I already said that machine learning models are simpler and lighter. Therefore, the deployment of these models in production are also lighter and easier. For example, machine learning models like decision tree model can be easily deployed on devices that has some constraints on resources. For example, smartphones. On these devices also, machine learning models can be easily deployed. But when it comes to deep learning, as you know that the models that are formed through deep learning are heavier and complex. So therefore, the deployment of this model in production will require specialized hardware as they are heavier. Now this specialized hardware can be GPUs or it can be dedicated processors for efficient deployment, especially in real-time applications like autonomous vehicles or video processing. So to achieve these complex tasks, it will also require large hardware support for its deployment in production environment. So I hope this point of deployment and the difference between machine learning and deep learning with respect to the point of deployment is clear to you all. And with this, we have covered every single point that is to be considered when we are comparing machine learning and deep learning. I hope the complete difference between machine learning and deep learning is clear to you all. This difference will surely help you to understand where exactly machine learning and deep learning lies in the world of artificial intelligence and what makes it different from each other. If you guys have any single doubt, then you can straight away put it in the comment section. I will be happy to solve it. If you guys have any suggestions or reviews regarding this video or regarding the deep learning playlist, then you can put it in the comment also. Do like, share and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Share this video with your friends as much as possible. Thank you.